today I would like to do an introduction to Neo4j, which is a graph database. But before, let's talk about me. I was born and raised in France, and I'm living in Japan since end of 2012. I'm unfortunately married, and the father of two beautiful daughters. So I work at Rakuten Osaka currently. Then, as for my hobbies, do you know the app called Anki? I'm a hardcore Anki.
How many cards?
I like getting done, and I really love quiz shows, and my dream is to become a quiz player. That's why I use Anki a lot. And I have some recent accomplishments. So in the last 2 years, so my wife doesn't speak English, so I guess I can progress my Japanese. And so at first I just wanted to pass things I have interest on, but then I decided maybe I should do something useful for work as well. So I decided to study Neo4j. So that's what I'm going to present today. So goals for today. So by the end of today, I hope you should understand what's a graph database if you don't know. Try to understand what are some of the use cases, and you should be able to read basic Cypher query. So Cypher, I'll explain later, but it's just like the SQL for graph. And hopefully you want to try out Neo4j in some project. So this is the agenda for today. So I did it quickly. Brief introduction of NoSQL. So NoSQL, I'm pretty sure everyone already knows what it is anyway, so it's not only SQL. So it's not a competitor with traditional database, it's more like a complement for specific use cases. So they are aimed to solve these three major challenges, which are data volume, velocity, and variety. So volume, like we have larger and larger data sets that we need to work with, and data velocity, which is a rate at which the data or the data structure itself changes, and data variety, which means that we don't have like very fixed structure. So if you use the schema, sometimes you have a lot of new values and a lot of new checks, new code. So there's 4 big types of NoSQL database. You have the key value, like Redis. You have column family like Cassandra, document like MongoDB, and GraphDB like Neo4j. So about Neo4j, so it's a graph database since 2007. The important point is it's a native graph storage, native graph processing. So it was made for graphs. It's ACID compliant, which is pretty rare, I think, amongst the NoSQL database. It's implemented in Java, which is the only bad point. It has community edition and commercial license, and there are drivers for Java, Python, Golang, and JavaScript. And it's ranked over Cassandra actually on the DB engines, and the first in the GraphDB. So, okay, that is. So there are multiple graph database. You have basically 3 types. First is the RDF triple store. You have hypergraphs, and you have property graph. So Neo4j is a property graph. So here you can see the main entities. So I guess you know graphs, so you have nodes, relationships. I think it's kind of that. Then you have labels. So you can label nodes. So if you're coming from SQL, it's like kind of table entity if you want to make a comparison. So here we have 2 nodes that are labeled person. And so it's a property graph. So nodes can have properties, and relationships as well can have properties. So if you just need to remember something today, it's like. So yeah, you might think it's another trend. I thought that at first. So it's not only a database. Like you have to think the world as a graph. I think it's at first it takes time, but when you try it, you can see like we're here all together tonight. So we have a relations. I mean, if you go drink later, we have another type of relation. And later, you don't know what can happen, right? So it's also an answer to new business use cases. Let's keep this one. So just briefly, what kind of usage you can have? So you can use Neo4j for social network graphs or for detection. Actually, this is like the use case that made Neo4j like kind of famous on graph database. It has like a couple of Panama papers. They had if you're interested, they have a white paper about that, which is pretty interesting. You can use for recommendation engine, which is pretty hype as a business use case. Knowledge graphs, network infrastructure monitoring, and identity and access management. So currently, Neo4j is trying to push more into the machine learning field because of the hype. So they like to call themselves white box machine learning. But yeah, very fast. Next, we'll do an introduction to the Cypher query language. So Cypher is Neo4j's graph query language that allows user to store and retrieve data from the graph database. So the syntax is pretty simple. It's declarative, it's spiral SQL, and currently the graph databases are trying to find the standard. Like we have SQL for a lot of RDBMS database. So hopefully there will be some graph GQL that would be inspired by Cypher. So if you kind of understand how to write Cypher today, then maybe if you use GQL in the future, it won't change a lot. So I've prepared a few queries. So this is the graph I'll use for the following examples. So you have the person called Jennifer and another person called Michael. Jennifer likes technology, which is graphs, and Jennifer also works for Neo4j. So we try to find the nodes labeled person. So to find, we use the match keyword. Then here we define node, like the braces here. Here you define the label, and here we assign the variable name. So we'll match all the nodes labeled person, and we give the name of P to that, and we just return P. So this query will actually return those two. So if you want to be more precise, we want to find nodes person whose property is Jennifer. So you can do it like that. So you still use match with the nodes, we look for persons, and then here we can specify properties. So we look for the property name with the value of Jennifer. So next we want to find which company Jennifer works for. So the same, we match Jennifer, and then we want to go over there. We want to get this one. So to go through relationship, we write it like that. So you have these dashes that represent the direction, which is very important, because the company does not work for Crequer. And here is the relationship type. And then you can fetch the company here, and we give the name of the company and we read it.
So the relationship, they have a direction?
Yes.
Okay.
So earlier we only took the company, the node itself, but we can also return only properties for that node. So the match is the same, but the return, here we have company, we just get the name property, and we can give alias like that, it's similar to SQL. So I think in SQL you put select first, and here is like in the end. but it's the same mechanically. So now we try to create nodes. So instead of match, we use the keyword create here. So we create a person with a property name of Mark, and we can return this. It's optional here. Then we want to create a new relationship. Say that Jennifer is friend with Mark. So first we need to match both of them that exist on the graph. So we need to retrieve them, and then we create a relationship here. So we can use the variable names here for the following query, and here we create a new relation. So if you run this twice, it will create two relationships. So if you want to avoid that, instead of create here, we use the merge keyword. So merge will work for the nodes and relationship node. We will try to fetch, and if it exists, it will just take it. If it doesn't exist, it will create. And you have some triggers as well here. So if you merge and actually it was a creation, then you can set some properties here. And if it was a match, you can do something else. So there's few options to filter the result. So until now we saw that to filter on properties we use like this syntax, but you can also use the where keyword here. Maybe it's easier to understand or to read. Then you have the notes here. We can do operational numbers. Here you can check that properties exist. So Neo4j doesn't store null. So if the property has a value or it's not here.
What about undefined?
There's no undefined. So for strings, we can start with contains regular expressions. We have as well the syntax as well for arrays. So now that we got the hang of it, we can try to do more complex queries. We'll find which people are friends of someone working for Neo4j. So we try to match persons friend with other persons, and that person here we fetch again. So this person works for a company named Neo4j, and we check that this pattern exists. So if it exists, it means that this person works for Neo4j, so we can return PR as the friend, all the friends of this person.
What would be R? But the team of P and friend are different, but R, what would be R?
R is the name of the relationship. Yeah. So next query, we want to find Jennifer's friend. We also share common interests. So try to do that in the SQL with that. So it's the same. We match Jennifer and what she likes. So when we define node, if we don't use like the nodes, we don't need variable name, and if we don't care about the label, this is how you get a node. And here's the same. Try to define persons. Which, anyway, you just can't hear. So you have like Jennifer that likes technology, and other person that like the same. So you try that. We also want to check that Jennifer is friends with that person, and we return all the names of that.
So you would say that, I mean, you can do this kind of thing in typical SQL, but it's more concise in terms of writing the query, right?
Yeah. Yeah. So maybe it's still hard to understand, but once you get the use of it, it's pretty easy to use. So just a summary. So yeah, you learn about the match keyword to allow to fetch patterns. Then the return, which is equivalent to the select in SQL. You can create and merge. So this works for both nodes and relationships. Where, which is to add constraints to the match clause. So there's a lot of order as well. So you have, of course, order by, limit, skip, delete. You can call. So call is kind of very useful because since since your database is a graph, you can use algorithms that are made for graphs, like the Dijkstra or the A-star, something like that. So you can call algorithms using this. Yes, I have a small demo that I can finish. We build a kanji graph and find similarities between kanjis. So we have some CSV files here. So here you got like the kanji of word, reading, and meanings. So it's like this is N5 to N1. So we'll try to import that. So Neo4j provides a
Can you import SQL data into?
yes, there are plugins for that, and you can also use some kind of
Logic.
like queue or to synchronize both. So you can have your main data on MySQL and then like push everything to the database and use some algorithms and then retry it on. Basically, you can use Kafka, so you can do a lot of things. Oh, version is a bit. So this is the file I distributed here. So we can load CSV like that, different row, and here we just merge is like just create. We create a kanji with the value of the like that. And after I just create value for the level. So here is N5 data, and I create relation. For reading and meaning I do the same. So if I run that, it doesn't compile. Shit.
that first thing, the first relationship doesn't have a direction. You get that?
Yeah. It will. It's not the cause error, but has. Okay. It's okay. This is the same, but I will import N421 as well, so it's a bit funnier. It takes a bit of time because it's just a browser. So this is like the Neo4j browsers, which is kind of free to use. So it's like the MySQL Workbench. So you can access your database from here, run some queries.
How many graph algorithms do you need to know to be able to really use it? Because I know depth first and breadth first, and that's basically it. I don't really know graph algorithms. So how far can you get without really knowing?
So this project and this demo here, I did as a hackathon in my company like 2 weeks ago, and we just executed 2 algorithms. So we have the Jacquard similarity, but it's very simple, and we used PageRank, like the Google PageRank algorithm, and we got pretty nice results. So you don't need to learn a lot to do things. And then after, of course, if you want to refine your solution, you have to go deeper into the all implementation because they have a lot of similar algorithms. So
does it have a query analyzer? Can you get any hints back? You know, like if I'm using an SQL database, a lot of them have query analyzers, and they'll say, yeah, maybe you should change this or that. But is there anything like that that says you should be using Dijkstra?
Not that I know,
Oh.
because you depend on what you want to do, I guess.
Yeah.
And since it's NoSQL, there's no like schema, so it's hard to know like what's the best because the data doesn't have fixed structure.
Right.
So we imported a few nodes here. So for example, we want to fetch. So So just fetch a node here, and we can see the relationship it has. So we have N5, some meaning and reading. Oops. Okay.
So what did you actually execute on the data? Can you explain a little bit?
Sure. So I just use the match on the kanji with value like kuni.
Yeah.
And I fetch as well all relations and all the nodes it's connected to, and then just returning everything.
So what kind of nodes did you create around it? Like the other words using that same kanji?
Yeah, so if I this is a node are created. So you have kanjis, meanings, readings, and the JLPT level. So if you want to find all.
Oh wow.
Whoa.
Yeah, that's real time.
Yeah. Yeah, just squaring. So you can get stuff like that, and then if you want to expand as well,
Oh, wow.
you can get stuff like that.
It's really cool.
Very interesting. So I have another data set.
So I have a question, sorry. How do you export the data in the end of the day? Let's say you find something visually interesting, then how can you export it to a format you can use?
Basically here is just a tool, but it's running cipher queries. So if you just need to write the cipher query for that. So the same way I have match here, you can have more complex.
No, it's fine. What I mean is like you end up with relationship between objects, right? So how can you export it to a format that can be used programmatically? Can you export to a JSON object or whatever? Or?
No, not like this. I don't know. I never tried, or maybe this. No, this one is just my first query. Yeah, I'm not sure you can with this tool.
Okay.
So since there's no schema, you can just add data on the fly. So I have another data set, which is the kanji radicals. So here you have radical meaning and the list of all the kanji that have this radical. So we try to import this. I'm just waiting for it to take time. So it's basically the same, just loading a CSV and matching, merging. This one's quite huge. If you have any questions while we're waiting.
So,
sorry.
go ahead.
Okay, so does Neo4j have a index on the property of the graph?
So
For example, if we run the query, the searcher on kanji kuni,
yeah.
if the Neo4j search all the kanji linear search, or does Neo4j have some index for searching the specific kanji?
So you can create index, but it is of course useful to look for the nodes. But I think the main difference with MySQL, for example, is once you get your first node, like the one that you match at first, then you don't index to get the others, because as I just briefly told earlier, it's a native graph storage and native graph processing. So it means that the data is stored so that once you get a node, it's easy to just start from this node and fetch other. So this is a good example when your data grows bigger and bigger, but that a part of your database is not changing. So you have constant performance on here, because you can add a lot, but it's somewhere else in the graph. You are not even looking at it here. So it has kind of constant performance.
Okay.
But if you want to get the first node and to put some constraints, you can use index.
Oh, thank you. This one.
I have a related question. Let's say you have many relationships and you want to get the first 5 of them, for example.
Yes.
Would you always get the same ones, or is it like random?
You get the same ones.
Same ones. So there's a kind of index then.
It's not a lookup index then.
Okay.
But, yeah.
Alright.
Yeah. You cannot search on it, right?
Yeah, I understand what you mean. So how does it actually order the results by default?
I think so need to check I think it's the inserted order, but like if you insert then you delete and you insert again, I'm not sure. So I would say insert order. So here we have more data in that. So now that we have data that we took from a kind of a master data here, we want to enrich our data set using some kind of algorithm. So here we try to run the Jacquard algorithm. So you don't need to know what it does, but basically you get 2 sets of like array, try to get the union, and divide by the number of the biggest array lengths basically, and it should create a score like that.
So does the algorithm needs to be written in GQL as well?
Yes, so this is provided by Neo4j. So you can create your own algorithms, but they provide basic implementation for a lot of algorithms. So they have this kind of similarity algorithms. You have PageRank, Dijkstra, and community detection algorithms like the Luna.
But you said this is open Cypher syntax, right?
It's Cypher, yeah.
So is it applicable to other systems using Cypher, or only Neo.js?
Currently only Neo4j. Because this is a library actually. that we imported in the settings. So just calling an external library. So we try to run this algorithm here. So what it will do, it will create new relations between our kanji nodes. So I will pass details, but here I specify that I want to have my kanji as a source for the relation, that I want to link them to other kanjis. So if we fetch our earlier nodes, you can see that it's connected with other kanji using a new similar relation here. This has, you cannot see, but there is a score, the Jacquard similarity score. So this value was generated and was different for every relation. So we talked a bit earlier about directions. You can see that these two nodes, they have the same similar relationship in the both directions. So sometimes it's not automatic, because this node can be similar to this one, but this one can be more similar to other and not to this one. So here, if you have double, if you want reciproc, you have to create reciprocity. You have to create two relationships. So just like that, we got similar kanji like this. So now we can try to, since we have new relationships, we can try to match on them and use them to create APIs. We can create an API that fetch similar kanji of specified one, just like that. And this is actually what we did in our hackathon. We created a kanji app to some kind of quick. Don't know if I can run it. Okay, so our hackathon theme was we wanted to create a kanji app that where you get a question like, okay, how do you read this kanji? But we didn't want it to be too easy. So like have the correct answer and like 3 random answers from like all the kanji that exists. So we tried to make it more difficult by to have the correct propositions, and for the wrong proposition we wanted to find similar kanji. So it was actually pretty hard to get sometimes. So we're just like with a few imports and a few algorithms like this, we were able to create some kind of real applications, which was pretty nice. We also won the hackathon.
Oh, wow. Okay.
Okay, that's it for my presentation. So if you have any questions, okay, next.
Is this graph why I can't read Japanese? I'm just looking at this graph and that's why I can't read Japanese. That's what I'm thinking.
Yeah. But if you use this kind of solution, then you can not learn kanji by kanji. You can learn a kanji and all the similar kanjis as a set, so it's easier for you to remember this kind of application.
It's possible, I suppose.
Is it possible to create a bidirectional relationship? Like before you had like an example of like Jennifer is friend with Mark, that would also imply that Mark is friends with Jennifer, but not always.
So you cannot create bidirectional. You have to create 2 relationships.
Right.
Can you find, for example, all the combination possible between country and other country?
What do you mean by
If you combine 2 countries, you make one word. If
Yes.
you combine 2 kind of other countries, you make another word. You can find this kind of relation too.
So it depends how you want to do it, but you can also have, for example, you have a list of words somewhere, you can try to import it and try to, because you have a word, you can create relation to each of the kanji that the word is composed of. And based on that, you can try to do some analysis like what is the kanji most used together, something like that.
For this language cipher, so
Yes.
is there any ORM for, let's say, Python, right? So mostly I don't write SQL, I just write some Python's ORM, right? So,
Yes, so there are drivers for Neo4j,
yeah.
but mainly, I think the majority of the time you will need to write cipher queries.
Okay.
I think for like MySQL, for example, it's all the same. You have a schema, so
Yeah.
you can have libraries that will like doesn't work for you because they know the schema, so they can provide function to create and this stuff. But for this one, there is no such function, so you have to write by yourself. They have some kind of implementation, for example, with so it's not really, but GraphQL, like the REST API, like no, it's not like, but so they chose a very bad name. So, for GraphQL, Neo4j is trying to create this kind of libraries to support the development. So even now, I think GraphQL is pretty easy to fetch like basic information. So you can create nodes and relations. But if you want to do, for example, here we just created this kind of Jacquard similar relationship. So if you want to fetch that, you will still need to write down the cipher code itself. Yes.
What's a good reason to use a traditional database store as opposed to a graph database?
So I think first it's stable.
I
I'm not
mean,
saying it's not stable.
more in terms of like the data structure itself.
Sometimes
If I'm starting a new project, why would I not use?
Because I don't know. So it's not like choose either or one or the other, but I think having a DB schema is good. This is like maybe the first reason I would choose my schema. Creation of estimates. And you have a lot of support still. Like it's really easy to just use and start from. And I think like this Neo4j and including other databases as well are made for specific use cases. So Neo4j is more if you need to work on like this kind of relationship first use case, then I think you should do that, because if you have MySQL, you will end up with a lot of joins, which is not the ideal. But yeah, if you just want to store like some kind of master data or have like basic information, like I still think that MySQL is the best tool for it. Yes.
So I understand that database are supposed to focus on 2 of 3 areas. So there is consistency, availability, and partition tolerance. And SQL database are ACID compliant and they focus on providing consistency, while NoSQL database are based and they provide availability. You cannot have both consistency and availability, so you have to do the trade-off. Either choose consistency partition tolerance or availability partition tolerance. So I don't understand how can NoSQL database like Neo4j be ACID compliant.
So it was made as compliant, so it's part of the requirements when they decided to create this library. I think for graph database, it's very important to be relation. Like, if I take example of Redis, which is key value, so you just have a key and value. You don't have links between keys, so you don't need to have this kind of consistency. You can just you can just provide basic availability and it will just write keys with values, stuff like that. But for relational database and Neo4j, you need this consistency because you want to work on relations between entities. So if you have one entity in relation but not the other entity, then you cannot use it. Your graph is just broken. So I think for graph database, it's very important to be ACID compliant. I don't know if that answers your question. Are you trying to trick me?
Camille, one last question and we need to move on, if there's any.
I have a simple question. For this desktop app, can I show the image instead of kanji? If I can give URL.
No, I don't think so. But there are other tools, like more advanced visualization tools, like the Neo4j Blue. When you
I can export to D3.js.
Yes. Yeah. This is actually D3, but you don't have any control. This is like just the basic stuff to try to play around your graphs. And if you have to do more advanced visualization, you can try to use another tool or create tutorials.
All right. Thank you very much.
Thank you.